This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com. Know-How is brought to you by the Ring Video Doorbell. With Ring, you can see and talk to anyone at your door from anywhere in the world using your smartphone. It's like caller ID for your house. Go to ring.com/knowhow and get up to $150 off a Ring of Security kit. And by Casper, an online retailer of premium mattresses for a fraction of the price, because everyone deserves a great night's sleep. Get $50 off any mattress purchase by visiting casper.com/knowhow and entering the promo code KNOWHOW.
Today on Know-How,
LED clock, part 1.
Welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Palliser.
And I'm Brian Burnett.
And for the next however many minutes it takes, we are going to open up the box in which all your knowledge is stored and add to the collection.
So I hope you've prepared your box.
Yes.
Because knowledge is going to go in there.
And I hope you packed it correctly. Otherwise, the Department of Homeland Security will...
It's okay. We're going to play a little knowledge Tetris, and we're going to put it in there properly, step by step.
There is an art to that, and I think it comes from the generation of kids who grew up playing Tetris. Like, if you've ever packed a car, you have to use every square inch, and it all depends on the sequencing.
Most of the fun is part of the challenge, right?
Sure, it sounds
yeah, that sounds
right. Folks, we're going to do a little something special here. This is actually one of the projects that pretty much everyone who's ever used an Arduino does at the beginning of their time, and that is to make a clock, right?
Right, which typically is kind of boring, but you've kind of gone above and beyond.
We got a little crazy here. The whole idea is we've taken our Arduino knowledge, we've taken what we know about 3D design and 3D printing, and we've made this. If you go to the side view here, this is actually a completely from scratch designed 3D clock that uses WS2812 LEDs and an Arduino to create this wonderful little masterpiece of geekitude. Now the whole idea is there's like how many parts do you think we had in our Cyberpunk goggles?
Cyberpunk goggles. There's each lens, the cartridges that you made. I don't know. I'd say maybe like 8 pieces.
Yeah, 9 pieces.
Yeah.
Like some of the other 3D projects, like the NanoBox, had what 5 or 6, and fairly complicated.
And it's rather small too, not like really big. You didn't use the whole bed on a lot of them.
This has 26 pieces, and each of those pieces has like 7 component pieces in it. So this is by far the most 3D design that we've ever done for a project on Know-How.
And it's kind of the coolest project.
Yeah, and actually, Kara, if you could bring down the lights. The problem is the lights, the studio, let's kind of zap everything out. There you go. There we go. So the whole idea is this is a 24-hour clock. Now, of course, that outer ring are the seconds. So it's counting up the seconds. And I know you can't see it, but every 5 seconds, the light turns. Actually, let's see if I can dim it at all. No, the next stop is off. Okay, so every 5 seconds is a golden light. Then we have hours up top, hours times 10, minutes, and minutes times 10. So this will represent everything, all the possible time that you can have inside of a 24-hour. Wait, it's about to flip over. And boop. Boop. Okay, so super simple code. We're actually going to show you that in 2 episodes. But yeah, this is about a $50 project, and that gets you some parts that you can use for future projects as well.
Yeah, and I think like most of our projects, just because you have it in this sort of form factor doesn't mean people can't modify it to a different look or something. But this is pretty neat the way you have it right now.
And of course, see, I've got a 3-button control at the bottom, and what it allows me to do is switch between modes. So the first mode I switch to, when it goes all rainbow ring, this is the time set mode. So this actually allows me to correct the time using this is the hour button, and that's the minute button. So it's just like setting the time inside your car. You click it one more time, and what this does is the animation mode. And this is just flipping back and forth the different animations that I've built into our little clock. Everything from, this is one of my favorite, the Cylon type look.
Right, which is you've used for the steampunk goggles.
Right.
Is it the same copy over stuff?
It's the same copy. It's been slightly modified to look a little bit better on this project. But I use this mode because it allows me to sort of test every LED to make sure everything's working properly.
Right, everything's getting power.
Yeah, but I mean, if you know how to code for Arduino, This is relatively easy for you to play with. Hold on, I want to go to Kara's. Kara's favorite is, I think, this one. Yeah.
So sparkly.
She likes the sparkles. Boom.
Yeah, and if you've been following along with the Arduino projects that we've been doing on this show, all this stuff that you're showing right now, we've done before, right?
Yeah,
It's just a different form factor.
Precisely, and this is what we've been doing. We've been building upon knowledge, upon knowledge, upon knowledge. People they've played with our Arduino projects, they've played with our WS2812 projects, they've played with our 3D projects. Now it's time to take something and turn it into more of a finished product than what we normally have a know-how, which is it works. It looks horrible, but it works.
There's wires poking out of it. No, this one looks pretty polished. But
one more thing.
What?
This ring is a finished design, but the frame, I deliberately made it kind of plain because we are going to be giving you the special STL file that will allow you to make your own frame for this.
I like that idea.
So yeah, we want to see what you come up with.
Right, and I mean, I've been seeing you work on this project for a while, so this has been kind of a little, not a struggle, but you've gone through a lot of prototypes, haven't you?
Yeah, it just, it was one of those things where I could have thrown something together really quick. This project, once everything is printed, takes you all of 30 minutes to put together. But I didn't like
the project. Yeah.
Like the first ring I made, I thought it was too thick. It just didn't look right. And the first series that I made, I didn't like the way that the little LED arrays in here looked. So I drew them a little closer to the center. They used to be attached to the outer ring. I didn't like that look. The first one actually had only one pivot. It was at the bottom. So you could turn it this way, not this way.
Right.
I thought, no, it's nicer to have the arms.
Yeah, I like that.
So this version is probably version 16 or 17.
Wow.
That's been a lot of wasted filament.
I was going to say there's probably been some failed prints, things that didn't fit together well.
Yeah. And a lot of this, like for example, the very first version, this worked, but the frame, you had to really crank it to try to turn it because it was so tight. This is now very loose. A little looser than I'd like, but it gives you the ability to play with it.
Yeah, and you probably have to be careful because there's wires threaded through it, so don't overspin it like Alex tried to do.
I put a lot lot of slack and I used 30 gauge wires, so I mean you'd have to spin this thing like 40 times to snap those wires.
It's
still working.
I like it.
Yeah, there you go, right?
Very cool.
Okay, let's take you through some of the things that you're going to need for this. We're gonna redo this when we get to the electrical portion because we want people to stay fresh. But there are a few things you're going to have to get. The first thing, of course, and Kara, we've got links for all of this, is the WS2812 60 LED ring. This is a specialty part. It's probably the most expensive piece that you're going to buy. And it's important because it defines the clock. The ring has to be this big to fit 60. And of course it's 60 because
60 seconds in a minute.
60 seconds. Although you never really use that last light.
60, yeah.
Because that last light flips over. But that's why we have the animation.
But we keep it even, so they're equally spaced.
Yeah. The next part you're going to need are individual WS2812 LEDs. We've normally used WS2812 in long strips, but these you could break them off.
Oh, cool.
So they come in packs of 10, and you can just snap them off, and then I've created frames that allow you to insert those into the frames and then solder them together into any order that you like.
I was wondering what those little things on the table were. I thought they were like pill poppers or something.
Yeah, that's basically what these are. The design that I created fits these perfectly, by the way. So when you push them in, they'll stay in even without the backing.
Nice.
Which is
so no glue required.
No glue required. I designed this entire clock to do friction fit. There are only 2 pieces that require screws, and I could have gotten rid of that, but I thought it was a little neater to have them. And we'll get to that in a bit. Even the buttons are friction fitted, so there's no adhesive. There's only 2 screws over here that hold this entire thing together.
I think when I used to put the airplane models together, they're called like Snap Tight or whatever. Yeah, very cool.
On the downside of that is, of course, if you remove them too many times, parts start to wear out, and then they get loose, and then they just fall out. But
I see.
But okay, that's what we got. The next piece, of course, is an Arduino Nano. We want to use a Nano because it's got more than enough power for this project, and an Uno is just too big. It just makes the base so bulky. And of course, I'm hoping you have a bunch of these. These are $3 each, or you could do what I did. I ordered a 50-pack for about $50 because you're gonna use them.
And you're gonna make a mistake.
And you're gonna make. I've burned out Nanos on the live stream. So
yes.
Yay. The next piece is because we're dealing with time, you need something that can keep time even after you shut off power, and for that you need the Tiny RTC.
We've seen those before.
Yeah, you can buy these individually for about $3, or you could get like a 5-pack for $5.50. So get the 5-pack, and it gives you some extras. Specifically get this model, by the way, because I designed the template inside of it to fit this.
Okay.
And yeah, that's a good thing. Now let's get to power. This is kind of strange. If you go to the UBEC link, Kara, there are various UBECs you can get. I'm using two of these because we do need enough power to drive all the LEDs at full brightness. You can get away with one. I wouldn't recommend it because if you get too bright, you actually overdrive the circuit.
Okay.
Also, you can buy a higher capacity UBEC for less money than buying 2 lower capacities. But I kind of like this idea of providing power from both sides of the string.
And equally.
And equally, because I mean, you can do that with one, but I kind of like having 2. It's less of a point of failure.
Okay.
Then we go from the UBECs to the power supply. This is going to take 12 volts, and this is why I want to put the UBECs inside the frame. I could just use a 5-volt wall wart.
Right.
But I wanted to be able to take any voltage. I didn't want someone accidentally plugging a 12 volt into it and blowing the entire thing.
Right.
This self-regulates. This will take any voltage from 5 volts all the way up to 36 volts and convert it back into 5 volts.
Nice. So yeah, you can plug it into next to your nightstand or something.
It's disaster resistant. That's what I like. The next thing you need is a power jack, and what I'm using is you can use this one. It doesn't quite fit. I'm actually using this one. If you come back to the table, it's the same price. It's just instead of a plug, it's a wire.
Oh, okay.
Right, and it's using the standard 5.5 millimeter. So right now it's powered down, and actually here's a good way to test the RTC clock. So if I plug this back in, it should come back exactly to the same time because that RTC is always running even when there's no power applied to the system. The next piece you're going to need are resistors. And again, don't cheap out on this, folks. Buy a big old pack. You're going to use these 10K resistors. I actually prefer the precision, but these will work just fine. These are the 5%, plus or 5, minus 5%.
Okay.
Precision are plus or minus 1%. And get yourself a big pack of these because anytime you do a switch or a button,
you're going to need the resistor.
You're going to need one of these. You're also going to need buttons, and what I recommend are these because they've actually been designed for this. These are the perfect size. They're 12 millimeter by 12 millimeter by 12 millimeter. You want the caps because that's what's going to fit inside the frame that I designed.
They have a good tactile button feel.
Yeah. Like that cherry switch. The click, click,
exactly.
Click. I like the click. All right, so next, and this is new. We haven't used these before, but we finally have to, diodes.
Diodes. Oh, yeah. Smitty's explained what those are to us.
They allow current to flow from one side to the other, one pole to the other, but not back the other way.
Right.
The reason why we're using these in this project is an Uno can actually power the entire LED ring, and it's still within, it's out of spec, but it's safe. If you plug in a Nano and there's no diodes to allow power to feed from the Nano to the LEDs, it will way, way overdrive the Nano.
And then
it won't burn, but it would just get hotter and hotter. And I know because
from experience.
I did this for an earlier prototype, and what happened was the Arduino got so hot it actually melted through the PLA filament.
Whoa, so that is pretty warm.
That's hot, yeah. Don't do that.
Scary.
That's scary. What you're going to see is when we get to the electrical, we're going to install them in line, and it will allow us to have the UBECs supply power to the Nano, but the Nano will never supply power back to the LEDs.
Okay. Smart.
That's good. And actually, that's something that we've been wanting to do. We should have done that for, say, the Aqua Base. Remember when we did the vase that lit up?
Right. Similar project.
Yep, exactly. Next bit are jumper leads. Super cheap. Get yourself a pack of these. We're going to be using these extensively because we need to make the little teeny tiny connections. And this is actually the super cheap way to do it rather than buying high quality. And of course, we need 30 gauge silicone wire. I'm using this because this is more than enough to carry the current that we're using. They're nice and small. Do yourself a favor. I know the plastic wire is about half the price, but we're talking about $3 here. Get the high quality silicone wire because it doesn't melt. The plastic will always melt. It looks bad, it smells bad. Get yourself some silicone.
And make sure you don't feel bad.
Don't feel bad.
So get the silicone.
Don't feel bad. And then let's go over the pieces that we're going to require for this because this is actually kind of fun. If you go to the overhead, this is what our layout looks like. So we're starting with this. This is the ring that holds the WS2812 LEDs. So all the seconds are contained in this ring. This ring goes into here.
Right.
This is the diffusion ring because we don't want the lights going directly into people's eyes. This takes the light and it kind of diffuses it. See, it gives it that nice
disperses.
yeah, dispersal look. And it's more pleasant. It looks a lot better. So this is our general frame. Into here, we're going to have these components. So these are the holders for those individual WS2812 lights. These are the backings. So once we put in our WS2812s, these actually will snap over the top and hold them in there. So even if you hit it, it won't fall out.
Okay.
And then these are the diffusers for those. So
that makes sense.
these modules go into here, like so.
Little pill poppers.
Little pill poppers. And then the diffusions are going to go on top, like so. This is a horrible assembly. And then I also have cable management. This cable management thing will go on top of there. That basically assembles the ring once you add in these. These are the bits that allow it to hold on to the base that we're going to create.
So my only question now is how big is it? Is this the extent of your bed that you had for your 3D printer?
No. You do need, we're going to talk about this, you do need a printer of a certain size. The Monoprice, Maker Select, and any of like the i3 clones
You'll be able to do
will
this.
be able to do it.
Okay.
This is the largest piece. So this is the base, and even on my Monoprice, which has a 200 by 200 by 180, I had to rotate it 45 degrees to make it fit.
I see.
But it does fit.
Well, there might be a challenge for some of the know-it-alls to make this maybe modular or something, or be able to divide up the project so that they can fit on smaller 3D printer beds.
Precisely. And then we've got the cover for the buttons, we've got the button holders itself, and then we've got the channels for that. And basically this all snaps together. Again, there's a total of 2 screws in this entire project, and it holds everything together.
Very cool.
Yeah.
I like it.
And what we're going to do is I actually want to take you through the design of the 3D pieces. Let's leave the electronics for another episode.
Sure.
Because I know there's people out there who have been just chomping at the bit to get more into 3D design. I'm going to show you how we put this together. But before we do that, you know what I want to do, Brian?
What's that, Padre?
I want to take a moment to listen to these messages.
We'll be right back with Know How in just a bit. I wanted to talk to you a little bit about a great project for you do-it-yourselfers, adding a video doorbell to your house. How about a video doorbell with motion sensing, high-def camera, microphone, and speaker? That would be the Ring Video Doorbell. I love the Ring Video Doorbell. I installed it myself, and believe me, I am. If you've watched the earliest versions of Know How, you know I'm not handy, but it was easy because the Ring kit comes with everything you need, including if you need a drill bit and a level, and it's actually a snap. I unscrewed the old doorbell. 2 wires are sticking out of the door. They actually do a better job with the Ring Video Doorbell. They have a nice plate that attaches with terminals. I put the wires on. And then you attach the doorbell itself to that plate using a proprietary screw, so somebody can't just come along and unscrew it. That comes with the kit as well, so you have everything you need. And then you pair it to your Wi-Fi. And once it's attached to the Wi-Fi, that doorbell is online. I can see what's going on at any time. Just turn on my Ring camera. In fact, let me do it right now. I can also, and you probably heard this happen, since all of us here at TWiT have Ring Video doorbells, you'll hear dun, dun, dun. You'll hear our doorbells ring. And, and that's because when the doorbell rings, no matter where I am, I hear it on my phone. There's the view of my front door for that's live right now. And you can hear it too. Oh, there's the mail person dropping off a package. So I can talk to the mail person. I can say, hey, just leave it there. I'll be right out of the shower. And what's nice is I see the package and I can keep an eye on the package. So even after the carrier delivers it, I have access to it. I can see it. Ring is a great convenience, but it's also a crime buster. In fact, there are neighborhoods. They have a whole neighborhood program now. I can join other Ring customers in my neighborhood, kind of a neighborhood, high-tech neighborhood watch. There's a they paired with the police department in a small town in Southern California. I can't remember the name, and they put every 1 in 10, not every doorbell, but every 1 in 10 they replaced with a Ring doorbell. Crime, that's 10%, but crime went down more than 50%. Because the crooks hate the Ring Video Doorbell because you can see them. What they do, you know, when you're at work during the day, they come up, they ring your doorbell. If you don't answer, they know you're not home. Then they go around the back and break in. Oh, and Ring's got a solution for that, too. They have now the Ring stick-up cams, which are basically Ring Video Doorbells minus the doorbell. You can put all around. There's no wiring. It's really easy to install. It has a little solar panel, and it's amazing. And they also have now the floodlight cam. So it's like, you know, you've seen those before, the lights that light up when people come around the house. That's a convenience, but it also has a camera attached to it. And you could talk to people. You say, what are you doing back there? Hey, you, I'm talking to you. That really works well. They run. They don't look to see if you're there. They run. So whether you're home or away, the Ring doorbell, the floodlight cam, the stick-up cam, they can let you keep an eye on your home. I love Ring. They're a great company making great products. They know home security. And it doesn't just stop at the front door. All you got to do is go to ring.com/knowhow. You get up to $150 off a Ring of Security kit. The kits include the Ring video doorbell and your choice of 1, 2, or 3 floodlight cam. This is a great way to protect yourself. And it works, by the way, not only with Amazon's Echo, but your favorite smart locks and hubs, too. Ring.com/knowhow. Save up to $150 on a Ring of Security kit. Ring.com/knowhow. And we thank them so much for making Know How possible. Now back to the guys and the show.
And we are back. Okay, so Brian.
Yeah.
We need to somehow turn nothing into this.
From the void of nothingness into reality. So how do we do that?
Well, people have been saying for a while we should use a more capable program than Tinkercad. And I absolutely agree. There are some, like Autodesk, they've got some great CAD software that is free. But the problem is the barrier to entry is still a little bit high. You know, it's a very steep learning curve. So I'm staying with Tinkercad at least for now until we get to some serious complicated 3D prints.
The stuff that you've been able to do with Tinkercad is pretty impressive.
Yeah.
So it's not really a limiting factor, is it?
No.
Using Tinkercad?
I mean, yeah, there's like an extra step or two, but they've improved the tools to the point where I'm no longer deleting parts of the print to get to pieces. You can now hide pieces, so you can get inside. You can group pieces together so that you could take a complex shape and turn it into a piece that you can drag around without worrying about accidentally leaving behind a circle. That's always been the big thing about Tinkercad, which is like you're designing and then you make a change earlier in the design process and you basically have to redo the entire concept.
Yeah.
You don't have to do that anymore.
Okay, cool.
Yeah. So without further ado, Kara, go ahead and push the magic button. The 3D design of our LED clock starts with the LED ring assembly. This is the part that will hold the 60 LED ring that represents the seconds of time and defines the overall size of our frame. Design starts by using a digital caliper to measure the exact width and height of the individual LED segments, as well as the overall radius of the ring. These measurements give us the required size of the outer shell and the inner shell. I created individual STL files for the outer shell, inner shell, and deck, then combined them into a final assembly that also incorporated holes and supports to allow me access to the solder pads, as well as keeping the ring from rotating within the assembly. With the LED ring assembly built, I knew that I needed a large print area. With the ring being 162.5 millimeters wide and the frame and supports adding another 20 to 30 millimeters, I needed a print area of about 190 millimeters square. So I turned to my trusty Monoprice Maker Select version 2, which can print 200 by 200 by 180. The next step was to design the frame into which the LED ring assembly, the LED boxes for minutes and hours, the diffusers, frame supports, and all the wiring would be installed. I didn't want to use adhesives or screws, so I designed the pieces to have tight tolerances for a friction fit. The design of the frame was simple. I wanted a strong backing of 2 mm, 5 mm of cable management space, then 7 mm for the ring assembly and diffuser, giving us a final height of 14 mm. The design uses a cylinder 166 mm in diameter with a hollow cylinder within of 140 mm in the center to cut out the middle. I then used 2 different sets of hollow rings, one the size of the LED ring assembly and one that was 2 mm narrow below it. This created a shelf for the LED ring assembly and the diffuser and a cable channel beneath it. Before saving this STL, I added ports along the midline where the support posts will attach. With the LED ring assembly and the initial frame complete, it was time to work on minutes and hours. We need a total of 25 LEDs to represent minutes and hours properly in a 24-hour clock, 9 LEDs for minutes, and 5 LEDs for minutes times 10. To keep our design clean, I included 6 LEDs for minutes times 10, though the last one will never light up during clock operation. For hours, I needed a second 9 LED array for hours and a 2 LED array for hours times 10. Together, those LEDs can represent every minute and hour between 0 minutes 0 hours and 0 minutes 24 hours. The design of the X9, X6, and X2 LED boxes are similar to the LED ring assembly and frame. Each has a diffuser, LED frame, and a holder that snaps together before sliding into a box with a slightly constricted lower area that will hold wiring. Once printed, the backing will snap onto the LED frame, which will snap into the diffuser, and the entire unit will snap into the box. Now, it's time to complete the frame. Importing the frame that we worked on previously, I added a cross channel at the midline, in alignment with the ports I created for the support posts. To that crosspiece, I attached the housing for all the hour and minute arrays, along with their own cable channel to allow for easy wiring. A set of 2mm posts along the wiring channel allow me to snap in a cable management cover to hide the wiring once done. The final step was to add 2mm holes along the frame and LED assemblies. This allows me to push out the pieces after assembly, just in case I need to do some troubleshooting. The final piece for the frame are the 2 support posts which attach the frame to the base. These are simple cylinders with flared ends that are notched to fit into the frame, while still allowing cable management and the installation of the LED ring assembly and diffuser. Speaking of the diffusers, for the hours and minutes, each is 2mm of transparent filament with 2mm posts that snap into the LED carriers. For the seconds, the diffuser is a 2mm pattern that uses the dimensions of the LED ring assembly to friction fit within the frame. Now we need to start thinking about the base of our LED clock, and that will require a special version of our frame. The frame_hollow is just a completed frame with supports that are wider by 1mm. We can turn this piece into a hole, which will allow us to create a mounting hollow in our support columns that are sized to just fit our support columns but loose enough for the frames to turn. The LED frame is the most complicated piece of this build, but the one that will take the most filament, more than 27 meters or about 80 grams, is the base. From side to side, the base is 208 millimeters long, which means it will only fit onto our build surface if we rotate 45 degrees. The design starts with 2 columns that are 20 millimeters wide and 123 millimeters high. Inside each column is a hollow cylinder, which gives us a column with 4 millimeter thick walls and a 12 millimeter wiring hole down the middle. I could have used cylindrical or square columns and the finished design would be stronger, but I decided to try out one of Tinkercad's special patterns for a little extra style. With the centers of the 2 columns spaced 188 millimeters apart, I imported our special hollowed version of the LED frame, rotated it 90 degrees, then lifted it into the columns until the tops of the columns were level with the frame midline. This carved out the shape of our support posts, with a little extra play to allow for free rotation within the finished piece. I also added a series of 2 and 3 millimeter posts at the top of the support columns that will allow us to snap caps onto the finished assembly. The remainder of the base consists of a wiring channel with dual 4mm wide walls to give the base extra rigidity, topped with 3mm posts to allow us to snap on covers. The centerpiece is a hollowed out 64x88 box that will hold the Arduino, real-time clock, and UBEX. The final touch was to add templates for the Arduino and RTC, as well as to cut holes in the back for USB and power. The last remaining pieces, covers, caps, and controls, were all created by syncing hollowed versions of the frame and base into the build platform, then laying the appropriate shape on top to carve out the required shape for fitting. These pieces would then be rotated for printing. Before you start, an important note on this project. You will spend days printing all the pieces for this LED clock. On our Monoprice Maker Select version 2, the combined total printing time was about 54 hours. And that doesn't account for misprints. Also, because you'll be using the entire surface, make sure your bed is level and calibrated and wipe down your build platform with alcohol between prints. But if you've got a printer with a big enough build area and about 70 meters of filament and a lot of patience, you can build yourself a mighty geeky clock. you will have noticed that in most of those prints, it starts off in the day and it ends late at night.
Oh, that wasn't just some cool effect where everything got dark in the background?
The printing for this takes a long time.
Wow.
I mentioned this is 19 hours.
Wow.
This is 12 to 13 hours, depending on how much quality you print. And then, the problem is everything else, you kind of want to combine it because otherwise you come back again and again and again. This is a lot of pieces to print.
So is this the longest print you've ever done?
Oh, by far.
Yeah.
Yeah.
Even more than the Aquavase platform and everything.
More, I mean, because
that seemed to be more
it's
stuff.
bigger, but I mean, that Aquavase platform took 18 hours to print, but that was it. That was the main piece. That was that in the LED assembly at the top.
Right.
This has 25 plus pieces, depending on how you count them. It's pretty complicated.
One thing I would like to see too is if you don't have a 3D printer, if maybe you were to try and purchase these parts through like a third-party vendor,
right,
like how expensive or how long it would take for them to do. Just because there probably are a few people who don't have a 3D printer that want to do this project.
Yeah.
I'll look into that.
Yeah, I mean, you can use something like Shapewise. I actually tested it out. At Shapewise, if you ordered from them all of these pieces in one kit, it'll cost you like $80. I know. At that point, I'm like, that's a third of the price of a 3D printer. Let's just go buy a printer.
Go get a printer, yeah. Or find a friend that has a printer, or find a makerspace like Aaron Newcomb's makerspace in Benicia. And I'm sure he would be happy to let people print stuff out.
Yeah, but I mean, just again, remember, you're talking about a lot of time. This, even at its best, and by at best, I mean, you can be there as one print finishes, and so you can scrape it off and put the next piece on. This is 3 days worth of printing.
Yeah.
It's substantial.
Well, the thing I was most impressed with is that how fast you've gotten at Tinkercad.
I know. No, that was all real time, folks.
Yeah, it was real time.
That's how I designed it. Just, I'm fast.
You've been playing with it for a while, so makes sense.
Folks, when we come back, I'm going to show you how this actually goes together. But first, let's go ahead and take another moment to listen to these messages.
Hey, we'll get back to Know How in just a second. Thank you, gentlemen, for letting me interrupt. Our show today brought to you by My Mattress, my Casper. It was last night. It was really hot in Petaluma. I think it was a 100-degree day. But the nice thing about the Casper, and this is not true of most mattresses, it is the coolest sleeping mattress. It's not cold, but I just mean it's I don't know what, there's airflow or something, but it does not get hot. So on a hot night, you'll be so happy you had a Casper. By the way, the most comfortable mattress I've ever owned. Casper is an online retailer of premium mattresses for a fraction of the cost. They're revolutionizing the industry by cutting the cost of dealing with resellers and showrooms. Now, I understand, and I know the first thing people say is, what, I can't lie on it first? They go, well, I want to lie on it first. You can lie on it first, but you don't have to lie on it, your new Casper mattress, in a showroom. You can lie on it in your house, and you can lie on it for not just 10 minutes, but for 100 nights. You have up to 100 nights to return it and get every penny back. They will come and get it. Makes it as easy as can be. So there's no risk in buying a Casper. There's a lot of reward, though. Cool sleeping, fresh, it smells great, it's super comfortable. It has a unique blend of give so that your hips and your bony parts are not, pressed against the mattress. They sink in, but it's also firm. And I need a firm mattress or my back will hurt in the morning. I love the Casper. It's comfortable, firm, lasts a long time. They know, though, that you got to try it first, and that's why they give you that 100-day trial. Casper mattresses uphold the highest environmental production standards. They're made in the USA, free shipping and returns to the U.S. and Canada. And by the way, good news, you've been telling me this, and I know you wanted it. They've added the UK. You can now get Casper in the UK. Yay! That is good news. Some terms and conditions apply, but we're going to give you a very good deal, an additional $50 off a Casper mattress when you go to Casper, CASPER.com/knowhow, Casper.com. Promo code is knowhow, and you're going to love your Casper mattress. Comes in this very compact box. I got one for, my son was sleeping in the dorms, very uncomfortable mattress, and I also think it bugged him that he was like, the 50th person to use this mattress. So I said, no problem. We're going to send you a Casper. It comes in a compact box. They really compress it down. He could get it up the stairs. He lived on the 3rd floor of the dorm. Open it up, put it in there. He slept on it all year. Very comfortable. And because it was so affordable, He said, well, now what do I do? I'm moving out. I said, just leave it. Leave it for the next guy. He'll be grateful. Casper.com/knowhow. Save $50 when you use the promo code KNOWHOW. Some terms and conditions apply. Casper.com. The best night's sleep on these hot summer nights. I'll tell you, you'll love it. Now it's time to get back to Know-How.
And we are back. Okay, Brian, so let's guide you through how we're going to do this. Now,
right.
remember, a lot of these steps you're going to want to hold back because you need to have the electronics in it before you do the final assembly.
Yeah.
But I specifically printed out this set so that we could put it together.
Okay, cool.
Right, so we're starting off with this. We have to add these two support columns to the edges so that it will fit into the hulls. Now,
Right.
I could have designed these so that this would just be part of the print design, but I wanted people to be able to change these out in case they change the base.
That makes sense.
Because we want people to customize their clock. So you can change these to fit any design that you make for the base.
Okay.
Right? So the way that this goes, it just goes right in. I had to use a Dremel to clear away some of the
Excess?
PLA. Yeah,
Yeah.
because it never prints circles perfectly unless you print them straight up and down.
Looks like it fits in there pretty good.
Yeah. There we go. 1 and 2. Actually.
And you're inserting it with the, there's like that little lip and that's
Yeah, the lip's
face
been
on the
designed.
bottom.
So this actually, I mean, look at that. It actually holds in quite well. It's, again, the friction fit. But I didn't want to count on that friction fit to hold this here. So I'm using 2 3mm screws. You can use any types of screws. I'm using the ones that we use on our quadcopter frames just because I've got a bunch of them. They just go right through the back. And assuming you have this thing properly lined up, it should go through the inside like, hold on. Let me be bossy here.
Tiny little screw.
Tiny, tiny little screw. Now this, if you print it out, on a printer that has decent resolution, it should, what do you call it? It should be able to hold it just from the tension of going through the screw hole. But I've also got tiny little nuts, just in case you want to give it a little extra something. You want to hold that like
That's
that?
what I was gonna say. I'll hold it. Teamwork, Padre.
Teamwork. We've got hosts
Gonna angle
United.
it to the camera a little bit.
right there. There we go. And you know, it's probably a good idea not to use an automatic screwdriver.
Right, over your,
Especially
your co-host's hand.
An automatic screwdriver that has a magnetic bit on a non-magnetic screw. Oh my gosh. This is going to kill you, Brian. I'm sorry.
And that's how Brian got a hole drilled through his hand.
You know what?
What's wrong? What's
No,
going on?
I just, because normally I would use a Dremel to clear out a little bit of the slag, but instead I'm going to use something I shouldn't. And I still want you to hold it just in case I stab,
Right.
because that would be funny.
We won't stab the table.
Now
Stab
it's
Brian's
a
hand.
metal screw, Brian. Doesn't look as good, but it'll get the job done.
This is for demonstration purposes. Look at that.
There we go.
Cool.
Okay, and we need one for the other side. Oh, this is not magnetic. And so, yeah, line that up.
Lined up.
So, oops. It's got to be able to push some of the PLA that's in the way. I didn't clean this as thoroughly as I would have liked.
Yeah, so you're kind of drilling it through it.
You know what? It's not actually lined up.
Oh, my bad. It's hard to tell, the black PLA.
There we go. Now it's lined up.
Okay, I'll hold it there.
There we go.
Ah!
Stop.
Ah!
Okay,
Oh, wait.
so what we have is this, and now if you come back to the wide shot, this fits perfectly, the wide shot, into,
Ta-da!
ta-da, and
Spin.
what you want? What you want?
I want to spin that.
Want to spin? Yeah,
Let me
right.
spin it. Whee! Nice.
And probably a future design, we'll talk about this in the last episode, but I want to add pogo connectors so that there's no wires. It's just, you can spin it as much as you want. It'll just keep going.
Yeah, so a pogo connector. It's how does it continue to transfer like this?
You've got like one pad that has nothing but the copper, and then you've got pogo connectors, which are just little brass pins on springs. So they'll apply pressure. Even if they move, they'll always be in contact.
Ah, okay, that's cool.
I just have to design it.
Right. No
I just
big
have
deal.
to make it, but it's cool.
No big deal.
All right, so now these are kind of fun because into these, if you go to the overhead, into these we're going to be putting our WS2812s, and then we're going to be using this. It's a backing that these are all friction fit. Again, you don't need any adhesives, and I've made them really tight. So once I put these on, I've basically made them useless because they're not going to come off without breaking.
Right.
But there we go. So wait,
You can hear them
wanna
click
hear it?
in.
Wait. Oh, I like
That's a satisfying click.
Ooh, wait, this the last one's awaits. Oh, there we go. Wow.
Now, is this is this to structurally hold things together, or also like help
It helps
direct the light?
Well, it helps to hold in the WS2812s.
Oh, okay.
This, if I didn't have this, you'd have straight light directly off the WS2812 array. This
Right.
diffuses it, hence the name for diffuser. But this is the same idea. It just clicks in, and once it clicks in, and you'll be able to solder your connections over here. It just fits right in. Now there's a shelf on this. I talked about how there's actually an area here. It's not a pure box where the walls are slightly more narrow,
Right.
or slightly wider on the inside, and so
So
it
it
can
just
only go down to a certain level, and then it stops like so.
Pops in. Okay, so if we were doing the LEDs, we would have already wired them up, and then you have that channel through the middle that you can then thread them through.
Right. Hold on. It's not completely flat.
These are
Now it's completely flat.
tight tolerances.
Well, I mean, that's the thing. You need the tight tolerances, otherwise this will just fall apart. Or it means you'll have to do something like use glue, which I really didn't want to. I wanted to stay away from glue if at all possible.
Right.
Hold on. Come on.
That's why I liked those little airplane models back in the day, because when I was like 8 years old, I didn't want to have to use glue.
Oh, hold on. Oh, come on, get in there. This is really, really, you know what? I may have actually made these. I wonder, oh, these might be the prototype pieces.
Oh, so they're a little slightly
I
too
made
big?
the box a little smaller since then, just
Okay.
because I wanted a smaller design. But no, you know what, Brian?
What?
I'm gonna bend this to my will. They're gonna fit.
That sounds not like a good idea.
What you got? Okay, so obviously you don't want to manhandle your design like that, but
that.
eventually it'll look like this
Okay.
if you go to the overhead, right?
That's pretty close to the finished product.
Pretty close to the finished product. Now, the LED ring, super simple. There's a slot at the top and at the bottom, so that tells you which way to orient it. And because you can't notice it on this camera, but they are slightly faceted, so they want to go in at the right spot.
Okay.
Because if you try to force it in at the wrong spot, they just won't quite fit right.
Right.
There you go. So it just goes all the way in like that.
Nice.
And then the diffuser goes over the
Goes
top.
on
And
top.
again, there's no wrong way to put this in because it will really only fit. You keep turning it until it fits in, and you just squeeze all the way around.
That looks good.
There we go. Let's see. And again, aside from the two screws that are holding in the support post, there is no adhesive, there's no screws in this thing.
It's all snapped together.
It's
It
all
looks
snapped
good.
together. The base is also similarly simple. There's a cable channel here, so once you have all your cables, you can just cover it up, make it look nice and neat. But for the base, it's the same thing. This is the button holders. The buttons are actually going to go into these little carriers. You see there? And then this will snap over the top, and it will keep the buttons from falling off of the frame. And again, friction fit.
I like it.
I mean, it's pretty on there. And this is also friction fit. So once you get this down, it's actually kind of hard to pop it up, like so.
So you have like little runners on there too. Is that just a structural thing?
Yeah, so these are cable channels. So that allows me to get the cable down from the LED ring over into this box where I'm going to be storing all of my electronics. But it's also 3 millimeters per wall. So what it does is this platform is giving it strength in this direction, and these runners are giving it strength in this direction. It adds to the overall strength of my 3D piece.
And that's partially why you made this all one piece, right?
Yeah, the original design had these columns as installable after, but by doing that, A, you're adding a point at which you have to add some sort of fastener, either friction fit or screws, and B, it really took away from the strength because you're only holding it by that little teeny tiny piece of plastic that makes contact. This way, it is a single piece. This thing, unless you smash it, it's not going to break.
Cool.
Yeah.
Looks good.
Yeah, right? Now, here's what we're going to do. We are actually giving you, along with the STL files for everything you print, the modified STL for this frame and ring, which has the slightly larger posts because you want a little bit of play depending on what your 3D printer can do so that this thing will rotate freely. In the original version that I made, the cutouts that are in the post were so form-fitting that it was like
Yeah.
So this is just loose enough for you to get your mojo on.
Right.
But you can take this and you can make this into anything you wanted. Now, you were saying you had this idea for making more of a square.
Yeah, I was thinking instead of like the circle, make this a square and make these a little bit more even inside or something like that.
Right,
but
right.
because I definitely want to keep the seconds, but maybe not use a ring, but just make it square, or maybe even make it look more like the TWiT logo.
Mm-hmm. And you could do things like making this an under cabinet mount.
Oh, there you go.
Or a wall mount.
I like
or
that idea.
on top of the monitor mount. I mean, you can do it any way you want. That's why we're giving you this file so that you can make a custom version of this.
Or if you have a smaller test bed, maybe find a way to make it modular, because this was the longest part of the print, right?
Yeah,
this was
by far
19 hours.
19
is that what you
hours.
said? I was thinking if there was a way to just do one post at a time, that might speed up, because the printer has to go from side to side, side to
Right.
side, side to side. So if you did a modular way of like attaching these together at the bottom and kept it structurally strong, you might be able to speed up the print that way and use less of your bed on your 3D printer if you
Right.
do have a smaller bed.
And one other little bit, and that is this. If you look at the back, you see all those little holes?
Yeah.
Those aren't just for show. What that does is it gives me a place to poke in a very small screwdriver so I can pop these pieces back out.
Ah, smart.
Because otherwise, once you have them in, they ain't ever coming out unless you destroy it.
Good call, yeah.
So, I mean, because you will make mistakes, or you'll have everything working and then suddenly one of the arrays will stop working.
And-
That's a way for you to get back in here.
Smart.
Yeah. In the next episode, what we're going to do is we're actually going to show you a little bit about wiring up this. Because
Cool.
this is a discrete piece. This is going to take you the most time of all the wiring, not because it's complicated, but remember, aside from the ring, which is 60 LEDs in 4 segments, each one of these LEDs has to be individually soldered.
Yeah, that's gonna be a little bit of a challenge. They're
and it's
tiny.
3 wires because it's 5 volts ground and then the data. And the data has to go from one to the next to the next to the next. So there's a lot of daisy chaining going on.
Okay.
Yeah. I do want to see you make this into something that's yours. I mean, I actually have a couple of ideas for some bases that are very TWiT themed, which I'll be cracking out at the last episode. But you know what? Jump into our Google Plus group and show us what you got. We've been so impressed by what some of you have done with things like our steampunk goggles. A few of you have made Aquabase models. Show us your clock. Show us your ideal clock, and we'll put it here on the show.
That's right. And yeah, there's a few ideas that I'm thinking maybe touch capacitive to change stuff on.
And that's totally doable. I have devices that we can attach to the inside of this that are basically Hall sensors. So if you touch it, it completes a very, very low voltage ground path.
And so it's like a button.
Yeah, and so instead of putting buttons, why not have it so that like if you touch this, it changes
I like that idea.
the minutes or the hours, right? That'd be kind of cool.
That would be neat. I like it.
The other thing you can do is if you want to go for a super, super crazy simplified version of this, you can omit the second rings, which again, it's the most expensive piece that you're going to buy. It's
But
$14.
it's the prettiest.
It's the prettiest, but you could make a super small clock if you have a very small printer that just has the hours and the minutes.
Yeah.
And you can reuse most of this design. You can reuse all the carriers. You can even reuse the code that I've written for it. But I kind of like the seconds.
I have become attached to the seconds,
I'm a fan of the
yes.
seconds. Folks, we know that this was a lot of information. We might want to make it very easy for you to find everything. So we put everything, including the links to the STLs and the Holo, so you can make your own base, at our show page. And Brian, where do they find that?
They can find those at twit.tv/KH, and this is going to be a multi-part episode, so while you're there, you can either download or, if you don't want to miss an episode, subscribe.
Yeah, and don't forget that you can also find us on the socials. You just want to go to Google Plus and look for Know How. Once you're in there, there's a very short approval process so we can keep out all the spam accounts. You get access to almost 11,000 Kitas.
Taquitas, know-it-alls.
The very smart people who are at all stages of their maker DIY journey. So you're going to find someone who has your experience. Maybe you can answer questions. Maybe you want to ask a couple of questions. Maybe you want inspiration for your next project, or maybe you took one of our projects and you made it better. Please, please, please go there. Again, go to Google Plus and look for Know How.
That's right, but if you want to see what we're doing outside of Know How, or me failing at some of the projects that we do have on Know How. You can follow me at cranky _ hippo on Twitter.
You really want the Cranky Hippo name.
I just want Cranky Hippo, but it's not going to happen.
Not going to happen. And you can find me at Padre SJ. And by the way, we've got a guest TD tonight.
That's right, Alex Gumpel. I finally pronounced it right.
Yeah, as Alex. That's
No,
Alex. No, that's Kara.
Kara!
It is Kara.
Kara, what do you do?
What do? I TD for Alex when he can't work late.
Because he's a wimp.
Yeah, mostly. And engineer, I produce the screensavers, and lots more, but it's a secret.
And where do they find you on Twitter?
At Kara080.
There you go. Until next time, I'm Father Robert Balacer.
And I'm Brian Burnett.
And now that you know how,
Go keep time of it. Keep time of track time of it.
I want animation. Whoa! Here, drop the lights. Drop the lights! Ah!